I will start the recording. So as I told you that the code recommend us a different type of elastic analysis techniques. So one is the response spectrum analysis. One thing more that I should emphasize, or I should say, that these okay. So one thing more, that these recommendation given to us by the code are, it is explicitly mentioned, it is for the length up to of 150 meter. So if your bridge span length exceed from this one, then you have to perform analysis based on the uh, based on the opinion of the designer, or sorry, the owner. And you have, in that case, you can either perform response spectrum analysis or time history analysis. So for example, if the owner wants that you should perform response spectrum analysis multimode or response spectrum, then you can use that one. Or if he says that you should perform time history analysis, in that case you will have to perform time history analysis. But time history is a very rigorous analysis, and it takes quite a lot of time. So mostly the bridges that we cover are less than 158. So therefore this table holds for that for them. One thing more, that in this code we have these three type of uniform load, which we will study: single mode and multi-mode and time history. So we will cover this multi-mode, response spectrum, and uniform load. So mostly these two will cover 90% of your bridges. Single mode is also similar to uniform mode, but its equations, it required a lot of calculation, and I would recommend that you should either use this thing, and if this thing is not allowed here, then you should use response spectrum analysis. You should not use this because it is a bit tedious as well. So okay, so today I will first go to this multi-mode elastic method, or which is simply known as the response spectrum analysis. So response spectrum, does anybody know what is the response spectrum? Anyone from the participants know what is the response spectrum?
Isn't it a pseudo model of the?
Yes, it is basically a pseudo acceleration. It is not the actual acceleration, but what does the response spectrum means? Does anybody have any idea what does it mean? So response spectrum is basically, I told you that we design buildings or bridges in our code based on a specific return period earthquake. So for a specific return period earthquake, the first point in a specific location, one is, this is the first point: specific ground motion, specific earthquake, specific ground condition, the response of different time period structure. These are the time periods. So for example, if we have a structure, this is a structure which has a period of 1 second, let's say 0.1 second, and it is hit by this earthquake at this site. So what will be the peak? What will be the response? So the response can be either displacement, acceleration of the structure, or velocity. So these three are response are basically these three things: acceleration, velocity, or speed. But mostly we use this acceleration, acceleration, velocity, or displacement. So at a particular area, for a particular ground motion, the response of different time period structure, when it is shown on a graph, it is known as response spectrum. So for example, for 0.1, this will be the spectral acceleration. For 1, it will be a spectral acceleration. For 2, it is the spectral acceleration. So what is the response? And one thing more, what is multi-mode? So multi-mode is basically, as I told you, that the uniform load method can confirm. The uniform load method works on the basic principle that we can analyze the structure as a single degree of freedom system. So we can analyze this structure as this single degree of freedom system in which the whole mass can be concentrated at one point and the force can be applied, and the stiffness of this column is the stiffness of the substructure or the bridge, overall bridge, and based on this analysis we can analyze this bridge. But in the multi-mode response spectrum, what we do that we divide the mass of the bridge into into multiple concentrated mass, and then we subject it to ground motion. So this bridge might be formed in different configuration, to a given ground motion, and all these configuration are added to give us a resultant, and that is known as the cumulative result of the response spectrum analysis. So this is a very short or brief overview of response spectrum. Okay. No. So in CSI, the response spectrum analysis is quite easy, and you can very easily perform what you have to do. You should come to the loads tab, and under this function, you should select response spectrum. So you should click this new one. So this window will open. So it contains all these different definitions. So currently we are using AASHTO 2006. So I will click OK because it is based on the 475A return period. So I will click OK. Okay. So now coming toward our bridge, our case study bridge. So you see it is in seismic zone 3, soil type D. So these are the parameters which I need to define the response spectrum in CSI. So acceleration coefficient is 0.3. Soil profile is, as I told you, the soil type 3 most accurately conforms to our soil type D. So this is spectrum. I will call it as a spectrum. And okay. So this is the response spectrum I defined for our bridge. This is definition is very easy. If you want to define,
Question.
yes, yes.
What about the damping? The damping will be left at 5%.
Yes, yes, damping is typically 5%. So
Okay.
okay, damping is in the code, it is explicitly mentioned. So thanks for pointing out, Mr. Arvind. So the damping is in all the codes, mostly it is 0.5%. So sorry, 5%. So this is the damping. If you have a specific damping, so then you can use that one as well. So mostly the design spectrum that are present in the code are up to the damping, 5% damped. You can define other spectrum as well. So for example, if you define AASHTO 2007, so AASHTO 2007 is based on this SSS1 FA, and these conform to the 1000-year return period. So these are all these SSS1 and PGA you can take from the code, or you can also calculate them, and these are the in the latest version of the AASHTO, the soil type are changed from 1 2 3 4 to A B C D E F. So in the latest version of the code you will find these type of soil profile. But the thing is that if you are using software, so the definition of response spectrum is not very difficult if you are using either the AASHTO previous version of AASHTO or the latest version of AASHTO. It is not very tedious. You can take these values from the code based on your specific site, and it will automatically create a response spectrum for you, just like it did for us. So this is the response spectrum for our specific site. Now this response spectrum that you define is basically a load pattern. So when you want to analyze the CSIBridge, so what you will do that you have to convert it to a load case. So in that case you will come here, this analysis tab. Under the load cases you should click this tab. You will see is the recording. Yes, okay, recording is under. Okay. So These are the different types of load cases. So our earthquake comes under the response spectrum. So I will select this one, click on this. So now please concentrate on this. So let it call response X, Y. I am using the same definition. Okay. So anybody know model combination? What is model combination? Anybody? So you guys should study the response spectrum a bit detail, what the different model, what is meant by model combination. So I will just give you an idea of what model combination is when I will perform model analysis as well. So one thing more, you might have used SAP or ETAB. So in SAP or ETAB, there is a this analysis model. So does anybody know what does this do? What does this model analysis do?
I kind of remember it has to do with the participation of the masses that you want to.
Yes, so basically I told you that the multi-mode response spectrum analysis is basically you discretize the structure. So it is basically a very advanced topic. So you should have a very good understanding of dynamics of structures and seismology to perform such type of analysis. But the thing is that let's say I am using this bridge. So uh, what in multi-mode is that you discretize this structure into these three different type of masses, and what you do that when you perform when you this structure is subjected to any type of lateral load, so this structure will vibrate in different configurations. So either it will vibrate, uh, I just I want to idealize it into something else so you can understand. So let's say this is a I idealize it as a structure. Let me open a lecture so uh, I don't bother with this drawing. So I will stop sharing the screen. I will show you what does this model combination means. Although it is very stop sharing. Although it is very intensive topic and the model combination is usually covered in the second last or the last lecture of dynamics of structure. But I will show you what does this model combination mean. So have you taken, Mr. Arvind, the course of dynamics of structure at your grade level or undergrad level?
Yes, I did dynamics of structures.
Okay, so which literature mostly you study? In our case, in our country, we usually study the Chopra book. So I think you also might have studied that. So Chopra book, you can call it as a Bible of dynamics of structure. It is very, uh, it is a, it is, you can say the best book available. There are people who have written books in the dynamics of structure, but Dynamics of Structure by Anil K. Chopra is the best book that is available if you want to understand the concept of structure dynamics. So let me open the lecture. Structure dynamics, lecture number 9. So is my screen visible to you? Is my screen visible to you? Yes.
Yes, it is.
Okay. So you see, this is the typical equation for the multimode analysis. So mass matrix, damping matrix, different. It is very complex equation, but okay. So these are the different modes. So for example, if you excite a structure which has these multiple modes, so it can vibrate uh, in this configuration. It can also vibrate in this configuration, and it can also vibrate in this configuration. So which mode contribute more to the you see the total load. So we, for that case, we perform model analysis and the combination of these different modes. So for example, for this node we will plus this one and this one. So these three responses for this node, sorry, for this mode we will plus this one and this response, and for this mode we will plus this. So how do we add them? So this is known as model combination. So there are different techniques for them. So one is this CQC. Let's call this spectrum. So CQC is basically cube. Uh, okay. So one is this absolute sum. So you just add them. The absolute value of absolute mean with ignoring the negative sign. So you add them. This is one of the method to mod add these different. One is this square root of sum of the squares. So what you do that you take the response, you take a square of that response. All you sum all the responses. For example, from one node, from one mode, from the other mode, from the third mode, and then you add them. Square of all the, for example, if you are taking displacement, so for example there it has moved 2 millimeter, it has 3 millimeter, and the other one has -4. So you will square them and add and take under root of the all these values. This will be the resultant response. The other one is the it is not mentioned here, the CQC. So I will search, ask Google sub CQC model combination. So it is okay, complete quadratic combination. So if I find an image, so this is the definition of CQC. So it is quite complex. I think I should not discuss this because it will confuse you more. So these are a different types of combination of modes. So I think I don't want to discuss this because this will become a bit more complex, because I think that you guys don't have a background of these things. So but the best one recommended by the code is this CQC combination. So we will use this one. You can also use this one as well, and this one, and these three we don't use. So these three combination are not used in the AASHTO. So we just have these three combinations, and we will use this CQC method. So CQC is the recommended one for model combination. For the combination, for the response of model combination, either it will be the acceleration, it will be the velocity, or sorry, it will be the velocity, acceleration, or displacement. So you can combine these all different types of combination using either of these three. The other Okay, the other thing is that use the standard acceleration loading, use modes from model load case model. So this will be default. So now, as I told you that we apply earthquakes in two direction, one in the longitudinal direction and one in the transverse direction. So for this bridge, we will apply earth seismic loading, one in this direction and the other one is this direction. And then we will use that code condition that I told you in the beginning, that 30% of one direction plus 100% of other. So I will show you how can vertical effect. No, we don't take the vertical effect, are mostly considered in near zone. So if your bridge lie in uh, uh, lies within 15 kilometer to the uh, say the seismic source or the fault, then in that case we take the vertical also. But mostly our bridges, the bridge we are taking into account does not lie in the near to the fault zone, so the near field effect is not taken. And I think this bridges are not built in such region. Only I just know only a single bridge in the world that is constructed beneath active fault line, and it is the Ryan Entrion bridge in the Ryan Entrion bridge in the Greece, and it has been constructed near the fault zone. So in that case, you will have to take the vertical effect. But mostly 99% of the bridges we don't take the vertical effect, because our bridges, we don't construct bridges near the fault zones because it is not very desirable. So we apply.
Aziz, just to tell you one thing, in the building codes, we have a vertical effect,
Yes,
even if it is in zone one or zone
yes,
two.
yes.
I think
No, no.
uh,
I will show you the building code. So the near field effect is taken in the code, but in zone one and zone two, they are not very considerable. You can
no,
check
no, no,
the.
no. No, actually, you are mixing the things. So actually, in the building code, vertical effect is always included because it will amplify the vertical effect, even if it is in zone one or two. That doesn't because the UBC is also referred that. So I can also share you that codal reference.
I will check that, but you are referring to the NA and NV factor. I think you are referring to them. So these are, but I think in the near field, they are predominant in the near field, not in the far field. So I will check it, but in bridges we don't take into account the vertical effects. And you can check AASHTO. It is mentioned there that we can do not take mostly the vertical effect, because in bridges the lateral response are predominant. I will also check what you are saying, but so okay. So U1 will be along, U1 is basically along this direction, and U2 is, so the scale factor I will, so scale factor is basically the value of G. Similarly, U2 we can add, so U2 is this. Okay, now here comes another part. So I told you that when we perform analysis, what we do that we take into account the effect of response modification factor based on our bridge. So our bridge, this bridge which we are using is categorized as other bridge, and and we have, let me open the slides. So we have multiple column bends, and I have categorized it as other bridge, So for this, the response modification factor will be 5. So there are two methods that you can accommodate the response modification factor. So one is that you can divide this 9.8 divided by 5. 9.8 divided by 5. So either you can do this, or you can divide in the load combination the EQ factor. The EQ factor, the earthquake factor by, for example, if you have 1.2, one dead load plus 0.5 live load and 1 EQ, so you can divide here it by 5 as well. So you can accommodate them it here as well if you do not accommodate it here. So this is about defining the response spectrum. The other thing is, as I told you, that we perform we take the absolute sum. So it is explicitly mentioned in the code that you have to take absolute sum 0.3 factor. Yes, so we will take that 0.3 factor here. So this is the directional combination. So you see in the directional combination, you will take the absolute. So what the CSI will do, that it will first take 100% of U1 and 30% of U2, and then it will take 30% of U1 and 100% of U2, and it will combine them and multiply it by the and it will give you the extreme effect of both of these. So this is how you can define response modification, response spectrum case.
Question.
Yes, yes.
You don't need, once you define the U1 and U2, you don't need to do the combinations. The software do the combination for you automatically.
Yes, this directional combination thing will perform the the directional combination for you automatically, and you can check the manual. They have mentioned it explicitly that this thing will cover your 30% and 100% combination. So you don't need. If you want to do it separately, so you can define U1 here and U2 separately here, and then, for example, response, you can define response spectrum X U1 separately and U2 separately. Then in the load combination, you have to adjust this factor. Then you have to make such a load combination in which 100% of one and 30% of other is taken. So it is better that we take this thing into account here. So it will automatically perform all the combination for you. I hope you got this.
Okay. Yes. Good. Thanks.
So this is how you can define the response spectrum. Now I will share another meeting link, because this meeting will end in 10 minutes. So I don't want to interrupt. So it should not interrupt us in the during the uniform load method. So I will stop sharing here, and then I will share another link and you can join using that.